All right, as we continue to explore the language of kinematics and motion, I've got two other vocabulary words we need to talk about. Let's talk about speed and velocity. So just like distance and displacement have distinctly different meanings, although they mean similar things, that's the same story with speed and velocity. Speed is a scalar quantity, and it just refers to how fast an object is moving. So speed refers to a change in distance over time. So if we think about it, something that's moving rapidly or that has a high speed is going to travel a large distance in a short amount of time. And in the same way, something that's traveling that has a low speed, that's slow, is going to go a short distance over a long period of time. And so that's sort of, we're familiar with the idea of speed. Now, so what about velocity? Velocity is a vector quantity, and it refers to the rate of change of position. So velocity refers to a change in displacement over time. Now, as we think about velocity, let's remember what this word displacement meant. That was that change in position. So let's look at that a little bit further and see what we can see about that. So speed's a scalar quantity because it deals with distance, and velocity is a vector quantity because it deals with displacement. And so we also have to include a direction. And these are the two words that students tend to get confused. And so let me illustrate something for you here a little bit. Let's pretend that our little Lego guy is out at the track, and we want to see something about his movement. So if he starts to run, and we run all the way around the track, he's covered a distance of 400 meters, right? But what about his displacement? Has he changed position? Well, no, he's right back where he started. So this is where we start to see a real difference between speed and velocity. So when he runs around the track, and we're running the stopwatch because we want to know how fast he ran, we can measure that because we know he went 400 meters, and we can decide how long that took. We can say the little Lego guy's pretty fast, and he ran 400 meters in 60 seconds. But what about his velocity? If we run this race again, and our little Lego guy goes 400 meters well, wait a minute. Was his displacement 400 meters, or did he go anywhere? His velocity actually is 0. And that confuses people sometimes, but if you think about his displacement, his change in position, then that should start to make a little bit of sense to you. Let's look at one more thing as we talk about speed and velocity. Velocity always has to, it's directionally aware, so we always have to think about direction. So if we were to draw an arrow like this, we could say it has a speed of, I don't know, let's give it a speed, 3 meters per second. But that could also be, he could have traveled like this and had a speed of 3 meters per second. But if we're just thinking about this arrow here, we'd have to say, well, that's 3 meters per second. Which way is that going? That's going east. All right, and so then that makes it a vector quantity because we've included this idea of direction. Here again, we could get to the corner, and this object or person, whatever it is, could change its velocity, and so now it's going 3 meters per second south. All right, and then we have another change in velocity, and we go. Let's see, what are we doing now? We're going 3 meters per second west. And one more time we can change our velocity and go 3 meters per second back to the north. Alright, and if we got through playing this little game, what was the displacement of this person or object? Because we began right here. Alright, so his velocity actually was 0 because he finished where he started. Now we could calculate his speed. We could say his speed along the path. We could total up how far he went and how long it took and come up with that speed. So I hope you see that speed and velocity are different. We're going to explore that more later, but for now it should give you an idea of what's going on.